Okay, in this video we're going to talk about intervals of increasing, decreasing, and being constant in our function of values. Alright, in this first part it tells us to take a marker of some kind, a highlighter, and for this first part it wants us to see if we can't highlight in the areas where we are decreasing on our function, and hopefully we see that we are decreasing here and we are also decreasing here. And then in those two areas where we're decreasing, we need to write the interval over which we are decreasing, and we are decreasing from, and we're going to use open parentheses here, don't use brackets. We're going to go from -5 to -3. And remember, we're using x values, not y. And then union, and then we're going to pick up with, looks like 4 and go to 6. So we're going to go from 4 to 6. Right, so for our next part, it's looking for intervals of increasing. So it looks like we are increasing from here to here, and that would be it. So those intervals for increasing, looks like it's going to be from -3 to 0. And again, we're using those open parentheses from -3 to 0. And then it wants us to find our constant, highlight where we're being constant, and that's going to be in this area here where we're not moving up or down. We're just staying constant. And so really you can think of this as slope. It's a constant slope, and that's going to be from 0 to 4. So again, the first one we looked at negative slope or decreasing. We looked at positive slopes, which would be increasing, and then constant or no change in slope or 0 slope, that would be our constant. Alright, so let's see what our next questions. It asks us, should your intervals be identified as a closed interval or open? And we've already said that we're going to use open, but why are we using open? And that's because at those endpoints, let's go ahead and just write it out. At the endpoints, the function, and I'm just going to abbreviate f of x, is neither increasing nor decreasing. Your function is not increasing or decreasing, neither is it being constant. It is just staying the same there. Alright, and then notice that for the next part it asks us to identify the domain. So how far to the left to how far to the right. And notice these are closed circles, so for your domain you would include, so use your brackets, and this is going to be from -5 to 6, looking at the graph. And then for your range, you're going to go from -3 all the way up to 5. So that's going to cover your increasing, decreasing, constant, And again, why you use your endpoints are going to be open. That's because you're neither increasing nor decreasing there, so you don't include them. And then you've got your domain and range here as well. All right, moving on to our next problems. And this is talking about some of your function notation here. So with some of it, notice the first part, it's asking us if f of x equals 0. Oh, nope, I skipped the very first one up there. Which variable x or y does f of x, does that notation represent? Well, f of x took the place of y. F of x is taking the place of y, and that's something you were told way back in algebra, but again, you may not remember. The next one, if f of x equals 0 for a given point on the graph, then where is that point located? And again, if f of x equals 0, then that point is on the x-axis. It's sitting on the x-axis. The next one, if f of x is greater than 0 for a given point on the graph, then where is that point located? And it's going to be above the x-axis. And then the next one, if f of x is less than 0 for a given point, then it's going to be below the x-axis. So we're either going to be on the x-axis, above the x-axis, or below, and it just depends on the notation that you're given. So very important for us to see that. So for our next part, it wants us to use a highlighter of some sort, and it wants us to mark where we're at on the x-axis, or above or below, given this notation. So for the very first one, f of x equals 0, where would we be on our function if f of x equals 0? Well, we would be either here, here, or here. And notice at the bottom it says to identify the x values. I'm going to slide this up a little bit. Identify the x values of where you would be. Well, those x values of where we would be at, x would be -3, or 0, or way over there at 6. So there's the first ones. Now let's go ahead and change over to the next one, and notice this notation says f of x greater than 0, so that's everywhere our function is above the x-axis. So that's going to be all of this that's above the x-axis. So how are we going to write all of that? That's a lot of value up there, so we're going to need our interval notation for that. So you are going to say, well, we're going to start way over here at -3, and it's going to be open. So -3, and it looks like we'll go all the way to 0. There's a bracket, 0, union, and then we're going to go on to the other side of 0, all the way over to 6. And then finally, our next problem, it wants to know where we are less than 0. So that's going to be where we are below the x-axis. So that's going to be these points down here. So to write those out again, we need our interval notation, and we need to be careful with this. Notice these endpoints are closed, so we're going to include them because we don't have arrows there, so we need to include -5 up to -3, but we're not going to include -3 because it's not closed there. We're breaking it off kind of halfway through that line. And then union, over on the other side, we're going to pick up at what looks like 6, and we're going to go to 7, and 7's at the very end of that line with a closed circle, so we're going to do a bracket there. So that should be all of them. Hopefully that's okay with everybody. If not, find time to come ask me a question so I can help you. All right, so let's move on. Okay, and again, should your intervals be identified as closed or open, give a reason for your choices. And for this one here again, we needed to have open endpoints. We had open endpoints, except for -5 and +7. And the reason why those were not is because those were located at the very end. These points were at the end of the graphs. With closed circles. Right, and now they want us to identify the domain and the range of the graph. So how far left to how far right, and so we're going to use included, and we went as far left as -5 to as far right as +7. And then as far to the bottom, we went to -4. All the way to the top, we went all the way up to +4. All right, and then we're going to go on to the homework problems. That's going to be on your page 26 and 27. I'm going to try those for homework. I'm going to continue on this and go through the homework, so you're welcome to keep watching to see your homework solutions, or stop the video, try the homework, and then come back to this to check your homework. Okay, this is day 4 homework solutions, and it's asking us to find each of the following indicated quantities. So let's work through all of these. So for number 1, we need to find f at 2, and the instructions are telling us that f of x is our solid line and g of x is our dashed line. So f of x, we need to find f at 2. Well, f at 2 is -2. Number 2, f at -1 is 3. F at 3 is -1. Number 4 is negative 2. Number 5 is 4. Number 6 is 4. Number 7 is negative 6.5. Number 8 is 2. Number 9, negative 4. Number 10, negative 4.5. Number 11, negative 6. And number 12, f of x being 0, that's talking about where it's crossing the x-axis. So x is going to be negative 5, negative 3, 1, and 4. Okay, these have got a little bit more to them. So for these problems, number 13, you're going to have 4 times negative 10 plus 3 times 9. And that's going to give you negative 13. Number 14, you're going to have negative 3 times, and inside your brackets, you're going to have 3 minus 2 times 4, I believe. And then that's going to give us negative 3 times 3 minus 8, so negative 5. And so that's going to give you 15. And then the next one, number 15, you're going to have negative 2 plus 2 all over 4. So that's going to give you 0. 16, you can draw your line there or no, just draw your line there and then make that one a lot easier. Draw your line through negative 2 and you're going to get 2 places, negative 4 and 2. The same thing for 17. You're going to get x equals, you're going to get negative 6, negative 2, 0, and 6. All right, number 18 is negative 10. And then 19 is 15. And then 20, you're going to have, let's see, 1/2 absolute value of x plus 3. And that is going to be equal to, looks like that's going to be equal to 3. And working your algebra with this, that's going to be the absolute value of x plus 3 is equal to 6. And then you have your 2 cases. You have x plus 3 equals 6, and then x plus 3 equals negative 6. And so x equals 3 or x equals negative 9. So there's your 2 solutions there. Okay, for your next ones, you're going to have from this equation here, 5, I need to make this a little bit bigger. You're going to have 5 minus 2x is equal to 3 times negative 2. So you're going to have 5 minus 2x equals negative 6. And so negative 2x equals negative 11. So x is 11 halves. And then number 22, you've got your x squared minus 7x is going to be equal to, and then it looks like you've got 7 minus, and F it through looks like negative 1. So we have x squared minus 7x equals 8. Now we're going to move our 8 over, so we have x squared minus 7x minus 8 equals 0. And then we'll factor that. We've got x and x. And what can I multiply that gives me 8 and then subtract to get me 7? So that's going to be a negative 8 and a positive 1. Setting each part equal to 0 and solving. So x equals positive 8 or a negative 1. Okay, now let's see. We're going to answer questions about increasing and decreasing. So the first part, intervals over which f of x is increasing. So we have from negative 4 to negative 1, union from 2 to infinity. Okay, number 24, intervals where f of x is decreasing. So we have negative 7 to negative 4, union, and negative 1 to 2. And then where we're constant, there are no intervals. That thing's not constant. Okay, and so same thing for g. So intervals where g of x is increasing. So it looks like from negative infinity up to negative 5. And then intervals where g of x is decreasing. That's 2 to 10. And then intervals where g is constant, that's negative 5 all the way over to 2.